Hello, everybody. Welcome to Agile Integration. My name is Wojciech Serafin. I'm a solution architect at Red Hat. I've been with Red Hat for about 3 years now. Prior to that, I had worked for Oracle, BA Systems. And I come with kind of load of integration expertise. So first and foremost, once again, thank you for coming, and joining us today. We really much appreciate it. Let's quickly go over the agenda of this session. We have a little bit over an hour. So we'll touch a little bit about the history of integration, not the entire history, but the last 10 so years. Where are we? Where have we been? How we arrived there? Why integration is changing and why it's harder, especially these days. Since the subject is Agile integration, I will explain the concept as Red Hat defines it. And we will have a quick look into technologies that support Agile integration. We'll not do a big dive into individual technologies or just brush upon them. There are a few new releases that came in that space, so I want to mention to those who are users and those who are not. We'll learn, of course, what these are. We'll do a quick, look into what we call our reference architecture for Agile integration. Then I'll do a demo, and then we'll touch a little bit about customer stories that we can share with you, which are public, and you can, benefit from experience of those. By any chance, if I might ask, who is using Fuse? I have a few people. All right. So let's get started. Since we moved out of mainframe, integration really started. When I was fresh out of the boat, 20-something years ago when I came to this country, I was working on one of the large insurance companies here, and on the first project that was done outside of mainframe. It was done on distributed systems on Unix and with a relational database. So that was the first one of my first experience of building integration. We had to suck the data that the company owned from the mainframe and bring it and populate our relational database. And it kind of, took my career into the sort of, integration space over the years from that moment. So you probably have seen that slide before. When you come to Red Hat presentations, various kinds, we like to show it. It basically tells us, where we've been in the last 10 or so years in terms of how we build applications and where, where the industry is going. And obviously, the reason is for that to be more competitive. The role of IT is changing from a cost center that was traditionally viewed into a weapon, right, and an advantage. And companies look at the IT as an asset. So I believe it was a guy from BMW that said, will be interesting to see if we, as a company, as a car company, will become a technology company, IT company, or that the IT companies will become a car companies first. So from two angles, trying to build the same product. When you look at the top layer, how we've built, integration over the years using, services and deploying them mainly on a monolith, the targets with the long development process supported by VMs on local data centers. However, and we're moving into something new. It's not all in one. Various companies adopt this approach in steps. So people start to adopt APIs and microservices even before thinking about cloud containers and DevOps. So you might have a mix of the top and the bottom layer at the given time. Now, journey to the cloud or to digital transformation is different for everybody. I assume most of you guys are from well-established companies. So your journey, it's not as easy because we carry all the legacy stuff that we have to work on and depend on, and has been there for years, and it's here to stay for a while. Now, if you join the startup, and one of my children is working for a startup company here in Toronto. Now, there are a completely different approach. They do everything in cloud. That's how they started. That's how they architected. So even their integration to the various backend systems that they have to do is done quite differently. So even things like concept of Agile versus waterfall, when I told her, or the discussion came about Agile and waterfall, he asked me, what is waterfall? These young kids don't understand waterfall. This is what we've been doing for many years. That was the processes. I remember when I worked at Nortel, the gating process was very, rigorous, a stringent process that you have to go through the project every time. And even when you add the column to a database table, you had to wait in lineup to talk to DBA and be approved. And you better have a good story for it, right? So it was really, really, really long approach. So integration history. Everything started, as I said, when we broke out of the mainframe, we started to have distributed systems, and all of a sudden we found that the silo systems need to exchange data, and various aspects of integration started to be deployed. File transfer, of course, then the messaging-oriented middleware came that made life a little bit easier. But you came with something like that when the system-to-system or point-to-point was talking and working and providing the conveyor belt for data exchange, right? So early 2000, a concept of service-oriented architecture came, and the poster child for software-oriented architecture was Enterprise Service Bus. So I was involved in multiple projects in that space where we were taking, what is on the left and building it to the diagram that is on the right. Actually, yesterday I was in one place that had on the big wall a huge diagram printed, I don't know, 6 meters by 3 meters. That it was a design of their systems. And in the center was the one place where all the lines were going to and in out, and that was 3 letters in the middle, ESB. So doing the integration with ESB on a greenfield was a rather positive experience. Things work out well. The new technology allowed kind of, a control of knowing who is talking to who, how much kind of data flows through it. You can enforce LSAs. You can have alerting if something goes wrong. And you had a central system to look at it with the console, right? On the development side, there was a lot of this race to make the development easier with drag and drop approach, where you would design the flows using graphical tools that will render the code, and the code will, of course, work, and etc. Or sometimes the drag and drop had the limitations because there were certain use cases that had to go backwards to implement them, right? So really what we did, when you look at this, all that spaghetti integration, the point-to-point, it was shoveled inside the belly of the service bus. And so the service bus became, the sort of, the thing that kind of rules everything, right? And as years have gone by, more stuff was added to it, and sometimes planned, sometimes unplanned, and problems started to show up. At some point, if one of those new additions caused a problem, entire service bus was affected for the most part, right? You have in Java, which these tools are mainly written, stack thread. There is no way getting out of it. You have to reboot the entire service bus. For HA, there were multiple instances of those. Sometimes I've seen up to 15 of instances of service bus run in places in order to accommodate, the demand. But there's also a conflict with the service bus for resources, fighting for the memory for threads. There are services where extremely heavy use versus those who were sometimes used. And so when we look at the SOA and ESB, what sort of negative stuff that was accumulated over the years was, you can see here, it was a slow team coordinations because you had to be, subject to release and be attached to applications, and at the same time, plan out in order to make sure that the traffic will flow as it should. The governance was one of the worst things. At some point, you didn't really know who was using the service. If you create a service that became a shared service, there was no really a process that would have the record of the clients of that service, and there were some tools that did some work, but never really saw a governance, never really covered that very well. And of course, the release cycles at the green field were quite decently, but as the time have progressed, they become much slower, right? Testing. That was one of the Achilles heel of service buses. It was very hard to do a unit testing on your laptop or in an isolated, sandbox environment. You had to deploy it to a integration environment and have actual real systems to which you would start testing to see the results of your work. And the worst one is the scalability, right? So if I have two services that are sharing this, the same runtime of the service bus, and let's say that traditionally a service called A is under much heavier load than the service B, what I want to do is I want to do this. I want this service A to scale up to whatever number of instances to provide a horsepower for this traffic to go through, right? I don't care, about the service B at the time. With traditional service bus, you would scale the entire bus. It would be another instance of all the services, and then sometimes we're, quite a number of those that had to be scaled up. So that's a little bit on the history. And the service bus is still here and is here to stay with some exchanges. And it's not that the service bus itself is a bad idea. The integration patterns that are provided by services are great. It's just that the model of deploying things together and in a large monolith solution, that's where the problem is, because you don't have this ability to juggle individual integrations the way you want, release them the way you want, and scale them the way you want. So at this day and age, integration is changing. I don't know if you heard something called SMASIT. It is really, about the digital transformation and integration at its core. So it involves integration with social media. Of course, enabling mobile applications, so providing a set of solutions for mobile application to work with the backend. Of course, analytics is the biggest thing, big data, gathering information from many places. I heard about integration that was done by one of the telcos that they went out into the social media to gather anything that was said about them, and especially try to figure it out how much negativity there was there in that sort of realm of social media, and then run through analytics. So they were sucking this, building integration pipes from various social media outlets and then analyzing it. Well, and then of course, it's embracing cloud. You heard today from our colleagues, about hybrid cloud and how companies are breaking out from traditional data center and going to a public cloud and combining those together. And Internet of Things. So it's not only people that generate data these days, there are devices, and there are plenty of those. And the devices will send tremendous amount of data, and sometimes you want that amount of data be also delivered in a secure and orderly way, and sometimes filter out on-prem where the sensors are, instead of sending everything back to the back office. And there is concept of API economy. So it was 2009, and Jeff Bezos said at one of the famous meetings on Amazon that from now on, anybody building a new application has to provide a set of API for that application. and if you don't follow, you will be fired. And then he was leaving and stopped and said, and if you do implement those APIs, and somebody calls you time after time to explain what those APIs do and how to use them, you also failed. So with APIs today, is the way we will build integration is not only for the internal consumption but also for outside world, as we'll be talking about. So what do we see as a new wave of integration architectures that we've looking out there, at what companies are doing using our technology and others. First, do-it-yourself integration. So as people build application, they will sometime start to build integration logic out of kind of curiosity into their code. At some point, the number of the integration points might grow. So out of the little application that was a Python doing this and that, it might talk to a database, to another system, and you find yourself that you start to see those tentacles coming out of this application in various directions, and it creates a bit dependency, right? So the application code right now depends on the specific system that are outside of it and for direct connectivity. Now, normally, we will do that through the service bus, right? In a traditional way, we say, okay, well, if you're going to this location, go to the service bus. Here it is. If we don't have it, we will build it for you, and then you will go for it, right? So the danger going directly, building this thing it goes back to the point-to-point, but it creates this type of tentacle monolith that depends on those systems, and then any change to those systems will affect you directly because your code knows directly about that specific applications, right? Or the database model or whatever, right? So that's one of the sort of, if you call it new wave, but it's in a negative way. This approach that as we move into the new applications, new generation of applications, or cloud native applications, whatever name you want to use it, we want to do a good job this time, or at least that's the way I feel it. That, well, we still have few years left to deliver, code and build. Why don't I do it, the best way I can now, right now, using microservices and everything that goes with it, and et cetera, et cetera. All right. However, not that part of being an application will be done in a new way and whatever. But the data sometimes that these applications are going to rely are still, in the sort of brownfield, all databases, all systems that needs to be accessed as well. So in this aspect, if you're going after that brown data, you add to your layer of your application, to your layer of your microservices, a set of integration services that will be a facade or proxy to all those systems that you need to depend on, right? And sort of expand the number maybe of those microservices, but then give yourself a way of controlling it, the access to that in an orderly, well-defined architectural fashion. And then the microservices. Everybody talks about microservices, right? And in a way, this is the new trend, and not everything will be microservices. Not everything is cut and necessarily has to be built in microservices. And the only reason why we build the microservices is for the flexibility, right? There might be other benefits, like certain portion of applications are much heavier used than others. They need scale individually. You don't need to scale, the entire application. But ultimately, microservices will have their own view of data. If we take, for example, order management system that will be built with microservices, each component might have a slightly different view on that data, right? And it might reach out to the backend systems like inventory and what have you, right, to interact it. So again, here, within the pure microservices flow of your use cases, there will be an integration endpoints that you have to implement, right, and add on to the microservice solution, right? And then lastly is the APIs, right? Building microservices applications is not easy. Building event-driven contracts is hard too. So most people adopt APIs. It is rather straightforward when a simple interaction protocol is a request response. Interfaces are well defined, they can be documented, and etc. Right? So for that angle, adopting a API type of communication between components becomes now a standard. At some point we had Corba, we had EJBs, and then the web services came. Should I have mentioned more details in that history? But the WSDL was terrible. I hated it, and it was really heavy. So now with this new approach, with the new protocol that are based on REST and JSON, you don't have to use XML because XML tags are overhead. You can define those APIs and make the integration working through it. So there are some trends that we see here. And any talk you will hear about microservices, if somebody does not mention an automation, there will be a faux pas. I mean, anything that I've heard and read is that they go hand in hand. You cannot deliver successful microservice application if you don't build automation. So ultimately, companies are adopting automation, and you probably heard our guys, talking about it big time. But usually what is happening is that the folks who build application start first, right? So they build this new architecture, they write their automation and that delivers the application and do the automatic testing and code promotion, etc., etc. But if you don't do the same thing for integration components, they will basically not wait, right? They say, we need this, and if you're not following us with the same speed of delivering your solutions, we will do it ourselves or we'll do it a different way. So integration components that we'll be talking about has to be also subject to automation, right? And what I mean by that is basically automated builds, testing, and promotion into, going through environments, right? The next one is cloud native. That term is quite widely used as well. But what I mean by that is that when it comes down to actual integration is that you don't just take an existing service bus as it is, as a JVM. I just containerize it, shifted, lifted and shifted right into the container platform. Running in containerized form. Even though I've done it because people ask me, in my GitHub are IBM Service Bus, Oracle Service Bus, and others, they've been containerized. It is rather ugly. You will not get the same benefits from it, right? So when I'm talking about cloud native is that when you build an integration solution, you make it cloud native, meaning it can run anywhere. You also take advantage of the platform features like probes, liveliness probe, as well as readiness probe, right? And you externalize out of this container anything that needs to change in between the systems, between the environments. Like secrets or certain definitions of locations, and you inject those into the containers as you move along. That you truly create a image of this container that is truly static, and you can tell that what runs in my lower environment matches what is running in my production environment, right? Have that consistency, which is sometimes, in today's systems very hard. You have things that are different in production that are in a lower environment. What we also see that there is an appetite for what I would call the business type of analyst, integrator. Certain companies and or either their line of businesses love SaaS offerings. Given the success of Salesforce and ServiceNow, nobody's arguing it. These people offer an excellent solution, software as a service, and many companies rely on it and using it, meaning that you have it, but they run it for you. However, you still need to integrate with things of that sort. And I've mentioned, social media. So there is a need of a high level of abstraction interfaces for building integration for people who are not necessarily programmers, right? And they can still do something with it and produce integration flows, right? And so that requires no installation and no management, and it's sort of integration as a service per se. So now we're moving into a Red Hat integration concept. Any question at this point? Because I've been running and talking. Okay, great. Let's move. So, well, agility, right? We have agile integration. So really what agility is, this ability for IT departments and development shop to be very responsive in their demands of business, right? And it really means move quickly and easily, and with even better results. Because ultimately, code that is not in production is useless, right? The same thing goes for infrastructure. You can build the most beautiful infrastructure. You can create, a private cloud on your data center. If nothing runs on it, well, what's good for, right? So, while we bring, integrate agility into integration, by leveraging, methods and tools that allow this agile and effective integration of services, API, data, and foundation, that give you a competitive advantage. Because you might have today a lots of investment that are valuable, and lots of money was spent on it. Is just how you can allow easier integration with the systems, before even you move to a new one, right? So those are typical challenges. I'm not going to spend much time discussing each of those. We have an excellent white paper that I have a URL location at the end of my presentation, so you can read about all those things, right? And the one that I find it often that service bus is really having hard time do it is to enable SaaS and integration across hybrid clouds, because really the traditional enterprise service bus, and I stress out enterprise service bus, was meant to do things on-prem, right, within data center. So this image actually comes from Gartner, right? Gartner calls this need for change that kind of is approaching, or approached, if you will, moving from traditional central hub integration into what they called pervasive integration. So integration everywhere, right? And it is that integration is in parallel with developing software with microservices, right? So for 20 years, we've almost done service bus, and like I said, it did serve quite all right for the times where we used it, but like everything, things around change it, and the time of service buses are really the large, enterprise service buses come to an end. And development wants to move much faster, doesn't want to wait for a single monolith solution to be updated, wait for its new releases, for new additions, wants to move fast because new applications popping up and new demands coming up, and integration it has to follow as well. So this is the definition of integration concept by Red Hat. What it really means, agile integration, is to be flexible, scalable, and provide reusability. So we do offer the flexibility based on distributed integration. which are lightweight, pattern-based. And the pattern-based is important. There's still all good stuff that Service Bus concept came with. We support over 60 integration patterns that you can work with to make your life easier. And when we move to scalability, it's microservices and containers and continuous integration and continuous deployment. And of course, the APIs, well-defined, reusable components, well-documented and widely available, easy discovered, onboarding new clients in orderly fashion, knowing who is using those APIs. So if I to change the API and propose new version of it, I at least know whom I'm affecting, and even though I might keep the old version for the next 6 months to 8 months, I have a clear vision of who are my clients, how much traffic they bring, and if there are APIs they need to be paying for it, I know the amount of consumption that they've provided. So with the distributed integration, there are basically 2 dimensions that I want to mention is that, as I was saying earlier, integration everywhere. So where integration is used and where it is actually placed, and who performs the integration. Traditionally, the integration was performed by a specialized group of people who were the sort of custodian of the service bus, and they were the go-to group. They called themselves shared services or center of excellence, you name it. Today, with the way things are moving, that model doesn't work anymore. And since you can deploy integration components anywhere, it should be really implemented by any programmer that does it, that delivers it. And in our case, Red Hat is not just a slogan. As you will see, we provide all the necessary components for this Agile integration to work. So there is the traditional service bus integration. So if you want to stick and do it old-fashioned way, running Java on VM, you can do it as well. We do offer support for CI/CD, microservices, and API management. The distributed data-driven event is coming. It will be added into a few our product later this year. Will be based on Kafka. And we have the low-code ad hoc integration tooling that allows a non-programmer or business person to take a crack and implement the integration. So going back to the first slide that I started with on being competitive, right? So this is where the API microservices and DevOps, CI/CD, container, and cloud belongs into those 3 pillars of API into Agile integration. And now let's talk about the Red Hat technologies for Agile integration. Any question at this point? All right. So the 3 products that support Agile integration is Red Hat Fuse, Red Hat OpenShift, and Red Hat 3-Scale API management. And really, when we talk about automation, Ansible is the to-go tool to help out, even though for the aspect of compilation and building containers, we will use Jenkins as well, as you will see. But those products are great, and I'm going to spend most time talking about Fuse and API management. Just touch on a little bit about OpenShift. I'm going to show it, how it's run and how we deploy those components on OpenShift. But this is a rather limited session. So, but all those things are great. But what makes this Agile integration work is the tools and process and people like yourselves who will be using it. And taking a different crack and approach to integration. So let's talk first about Fuse. I said few guys know about Fuse. So Fuse is based on Apache Camel. I actually had the pleasure to meet the key guy behind the Apache Camel, Klaus Ibsen. couple of times, and kind of amazes me that all those years that I work, in this integration field, that I never really, gave enough attention to this technology, because the way Camel is written is really so flexible that when it's used does not really force you into specific. First and foremost, a development approach. You have several. You can use Spring integration. You can use Bluemix. You can use Java. You can use Scala, I think, and we have 4 or 5 other, 3 others, domain-specific languages. So does not really force any specific model in terms of how the data flows through it. Is rather open, doesn't have any conversions of what you send is actually what is going through the Fuse integration flows, and it's really efficient. And the way you can build integration with Fuse, that you choose the components that your flow needs, and in the project you will use them, and that's where it goes into a compilation process. You don't bring the entire bus with you, regardless if you want it or not. So there are the options of Fuse that you can deploy on. So Fuse standalone. This is traditional way of building, solutions as we've done it, running JVM on a VM, and what's called classic integration. You have choices of a runtime that is Spring Boot, OSGI Carafe server, or our JE server, JBoss EAP. Then there's the Fuse on OpenShift. So this is something I will be focusing today mainly. This is how you build what you will really call the Agile integration. This is where the Agile integration really lives, and this is the benefit of using Fuse in a containerized form and building integration as a small components, sort of microservices, and deploying it and managing it at within OpenShift container platform. And then I will show you a little bit about the new kid on the block, which is Fuse Online, which is called iPaaS. This is the ad hoc integration, high level of abstraction, browser-based designer that allows you to take a source of your data and destination and build a flow of data processing. And this is a little bit about tree-scale API management. So the way it works, it comes actually in 2 flavors. The first one is SaaS offering, where this portion is being hosted by us in the cloud, and the gateways are your responsibility, and you deploy them anywhere you want. So you become given an access to admin console, and then you build your branded portal for APIs for developers to discover, and you manage it using our hosted admin portion. Those traffic managers gateways are your responsibility. You put them as many as you want, and they will be communicating with your management part, and for instrumentations, what to do and what type of policies to enforce. The second one is the one that you deploy everything on-prem, that includes this and that and this, and will run on OpenShift. This can run on OpenShift, can run outside, can run in a native form, can run in as a Docker on the outside of OpenShift, so and can be deployed in various areas of your stack, and go to DMZ inside. Architectures are quite rich in terms of what you can do with. So, the admin console, first and foremost, provides the access control, and where you would say who can log into it as well, right? And you can define security for your APIs. You can enforce consumption price, rate limits, and you can document your APIs there, provide the documentations for it. Then some of the stuff will be rendered through a developer portal where developers can come in and look what APIs you offer, apply for usage. You will offer certain plans that they can use, some of them free, some of them might be paid. Then as the data gets collected by the gateways and sent, you will run analytics and reporting on usage. So think of this that first you instrument everything about a API, and the gateway will enforce it, starting with security, with access control, and then the rate limits for that API for a specific customer. And it can be done per customer basis, right? And that's where the, so really, when you think about APIs, the building APIs is like a tip of the iceberg, and managing it is really, really a challenge, right? Like I said, so first and foremost, you have to know who are the users of this service, how much volume they are bringing. Should you, charge them? Some of them might be more important than others. So some will have a platinum plan, others will have just a bronze, and will have a limited resources given to them. So everything can be controlled and configured, right? So as the consumers come in and make a request through a gateway, the gateway is the sort of traffic cop that will enforce all the decisions that you made for a specific consumer on that specific API, and then the API actually will be hit. I'll show that a little bit in the demo. So those are just a quick samples of typical integration. You still have a traditional integration with legacy APIs or external and internal APIs that you want to access, and microservice-based APIs. In that white paper that I'm going to say, there's more about it. So I'm just going to move quickly forward because we're running out of time. The reference architecture. So now you have a basic understanding what we as a Red Hat think about what is a Agile integration, and we do provide a basic idea what the reference architecture should be. So the core principles, yes, it is microservices based. So small components, you will tolerate little, tiny buses with just enough bus in each service that the integration flow required. You don't bring the whole thing, right? We have 3 layers of this abstraction that I'm going to talk about it. Provide, aspect of legacy integration, dump pipes and smart endpoints. Meaning that if microservice is talking to a microservice, there's very little in between. There is lots of transformation and things going on. Loose coupling with API-based integration, and a stateless integration. If you need a stateful type of integration, you go to things like BPM, right? Which is a product that we do offer, but it's more of a long-running processes that resemble business processes within the company. And leveraging API management on various tools. So just a little bit about dump pipes and smart endpoints. Well, this is the World Cup today. It started a while ago, so I figured it out. I use this imagery. So this is how the players, where you can use hockey ring, for the same token, pass ball, the same thing. So there is very little in between. There is no more like big service bus through which you would imagine all, current days you will have a service bus here in the middle, and they will have to all pass through the big service bus. That ain't happening anymore. But there were good things about service bus that I said, like the centralized console and things of that sort. And we don't want to lose that. So since you run this distributed thing, we still want to have one console that will show all the integration in one place. And that's where we added Infuse recently, 7, to capture all these integrations that are running on OpenShift and provide the visibility of it. But the same thing, tracing of those passes are currently we've been using Zipkin, but a friend of mine here, Gerald, was demonstrating using of Jaeger. So this is that tool that traces, the dependency, who calling good and how many and whatever. Just sort of give you the dependency and a logging on those on that level. So you can create that mesh of dependency. So there's the reference architecture. I like to call it, like hotel booking approach. that we have options to use. When you look from the bottom, those are would be a base microservice layer that has kind of, domain focus, very simple. They have the domain context, right? So that would be every hotel chain that you have today. You have the Marriotts, you have the Hiltons, Best Western, second Best Western. Then you move up and there is the composite layer, right? Where we will use some of this stuff that these guys provide and aggregate and build an aggregation of it. Additional things here will be event bus that can capture events that are happening and distribute those events as well as things like caching. You might choose to cache certain data that is frequently used rather than just going back and forth to a database. So those will be, in the hotel world, will be the Expedia, Hotels.com, that these people go to these places to pull the data and kind of give you the idea, right? And the gateway layer is where the policies and are enforced. This will be that guy that comes up on TV all the time and says Trivago. So he has access to everything, right? However, the gateway will be existing here as well and here, right? So this is just a sort of funny thing that I thought about it, how to set it. Now, don't think this is a cake that like this layered up. These things will be dispersed, distributed like that soccer field, and they will just use each other as they please. So if you have to here, build something more sophisticated, and I have a use case that we're gonna talk about a client. Like each company has a view of client, right? And each company will have, sometimes the larger ones has multiple businesses that serve services, multiple line of business that sell services to the clients, like the telcos, the banks, or insurance companies, right? And so at my telco or at my bank, I might have several services. So when I present myself, they should know all these things, right? So they have to pull that information from multiple sources, right? And those sources will be, obviously, provided by the lower layer, and sometimes, the legacy integration systems that still need to exist, right? So that's in a naturally referenced architecture. Again, you can read more about that white paper that we have. It's quite substantially providing, all the information about it. The demo, right? So I hope I could have shut up and just do the demo, but I'll still have to talk. So we'll use, again, little sample of the client API that is reaching out to a database to pull the information from. We'll first do a quick development on local, running it locally, using IDE, deploying locally on OpenShift, the mini-shift version of it. Then we'll talk about a little about the automation. We'll engage API management. And then lastly, we'll talk the Red Hat Fuse Online, which is the sort of high-level non-programmer targeted solution that we just brought into the market. So let me switch that off. So those who use Fuse, you will see that's JBoss Development Studio. This is based on Eclipse. I have the project here. And then resources. So this is the flow. Basically, I have 3 methods. And the one thing I like always to do, and when you do microservices, you should always consider that, have a health check type of service. It's a dummy that says, okay, I'm here, whatever. So there are 2 business methods to get, customer, by ID, or they get, customer, all customers, right? And so normally this is, the drag and drop option that I've mentioned, that you still have it. So you drag and drop, and you create those routes. They're, in this case, as you see, reaching out to a database in this case, right? So first, and I want to run it. I don't have a database. I'm just was told how the data model looks like, so I can quickly recreate it. So I'm going to use what is an excellent, and again, feature of Fuse, which is their ability to do the mockups. So testing was hard during the service bus times, and Fuse and Camel really made an attempt to create an approach where you can mock up almost anything that you're going after in terms of integration. So I don't need to have built, right in a database. I can just run it, and I will use in this case So I have this local profile that is going to do a clean and Spring Boot run, and we'll use in-memory database called H2. All right. I would have to, oh, damn it. So as you see, it's building. I don't know why doesn't want to engage. Oh, changing the font. So I'm running a build, and this one is coming up. I don't have any database, right? And per se running that I need to come on. This one reacts. So I can hit, that one of those methods on this API and tested it out. The mock-up database that provides the data model that I am using in this case, in this sample, very simple example, provides me a feed of data that I can know that my API works, right? And I'm decently happy with it. So the next step, say, fine, I'll try to run and build a container with it, right? So I have a mini shift running, and let me increase this one. So I have a local mini shift running, which is a all-in-one OpenShift, right? I'm gonna log into it. All right. That's interesting. I restarted it, something happened. So the way things work, right, is that you can deploy directly from the OpenShift IDE, right? And then we have a set of Maven components called Fabric 8 that when executed as a target, it will run the build, binary build first, and it will then merge that build with a base container that for OpenShift in this case will be a Spring Boot JVM container, right? So, and it will deploy to OpenShift, right? So, that's better. So for those who never use OpenShift, OpenShift has a concept of project, which is basically a namespace where you can group your deployments that kind of belong together. So I'm using command line to actually communicate with OpenShift and then created it. And here I am in OpenShift itself. So I created this project, it's empty, there's nothing in it. Now, when I was running the first test, I just ran it and I asked it to mock up a database for me, which it did. We ran the test, I think I was successful. So now I want to actually use the real database. I want to create a MySQL database, which we do provide. So I'm going to create a container for MySQL. Right, and right. OpenShift is starting up a container based on the image that I selected, with the credentials and everything instrumented as I've asked for. So now we can go back to our project and then I'm already in it. All right. So the database is up, as you see here. So we're going to execute the different Maven task this time, which is this one. So looking at this, sorry for the small font, and I don't want to, because I'm running out of time. This one was just building a Spring Boot and running it. This one is going to go and use Fabric 8 deployment, which all the configuration, what to do, which project to use, where the OpenShift is, were allocated when I created this project. It asked me for it, and I've provided information. So it has been instrumented to execute the second phase, which is building of a container, right? This is building. So first, the binary build of compiling Java code using Maven, it's happening here on my Eclipse. And you will see, or it's already finished the build. That was fast. And as you see here, downloaded the binary into OpenShift and created an image. When an image is created, a deployment starts, and at this point it's actually building a container based on that image and spinning things up. So at this point, it's coming up, that application. I can hit it. And it's working, right? So the whole magic here is that you got this component, which is this Fuse integration Spring Boot application talking to this database, right? So there are two containers. I mean, I can go and show you the log files of it, right? I can, if I choose so, SSH to it. I'm in a JBoss directory. Going back what I was complaining, the traditional service bus, the scalability of it, and what it could not do it for a single service. If you've seen, my colleague Elliot Gerald doing it, probably he did the demonstration of the scaling up of the services, right? Now, I'm forcing this thing by the GUI. You can do that from the command line, but you can also set up a thresholds that will kick in additional containers, depends on the traffic as it goes and how it flies. I'm quickly going to switch this to this one, where we will talk about how you automate, right? Because what I've done is sort of, developer concept of testing locally using mockups, then trying to break out of your own, IDE of your own laptop and going into a containerized form, because ultimately that's the destination, testing it out in that such fashion. But when you do that, then you check your code in. Eventually, you want to run a pipeline build. I'm not going to run it, but you can automate the actual build, taking a source code from this is what this thing does. The first step is pointing to a location in the GitHub where the code I've stored, pulling it out, running a build, then generating a container, deploying into a first environment, which in this case is that project called Fuse Lab Test. And after deployment, it will run the test. I will ask the question, do you, upon successful testing, do you want to promote it to QA? You go, you provides you with the choices, you do it, it promotes to a different environment. There might be changes that you need to provide, that you externalize to change something in the container content, but not the container image itself, because the Q environment might be pointing to a different database, and you can have to deal with that. And that's obviously very easily done through the config maps and injection of secrets, right? So that is the first sort of, quickly on automation. And then just for the fun, I'm going to run so you will see what. I can switch because this is a visualization of Jenkins run, right? So ultimately, what is running behind is the Jenkins pipeline. So obviously, I can switch to logging of Jenkins. And as you see here, it is executing. And if anybody who has seen Jenkins' beautiful GUI, I'm there. And the only thing is that this Jenkins is running on OpenShift 2. You can run it outside. It's your choice how you want to do it. And you can run master outside, slaves inside. There's also a combination. But for the purpose of this demo, I have a container that is Jenkins running here, providing the sort of, a fuel to run the pipes. And this takes, like two minutes to do it, and you'll observe it. So now we go into a API management. So I have a project here that I call it prod, right? So what you see here is, so far we had two components. We have the source of the data, which is the database. In my case, it's MySQL. And then there's the integration component that is that we've built with all these APIs that relies on the data provided by that database. And then right now we introduce a third one, which is the actual API management gateway, right? So it is here. There are two of them running. So the only way to access the API is through this URL. And that URL is pointing directly to those two pods. So from outside world, I cannot directly bypass my gateway and hit the API, as I've done it previously, right? Because I made a conscious choice that this is the layering of access that I'm going to do. So the only way outside world is going to communicate with this API by means of using this URL that will hit the gateway. Gateway will do whatever was told for that client, enforce all the necessary security / plans, and then we'll push it to the actual API implementation, which then go into a database, right? So how that really happens, how this gateway knows about it, then how that instrumentation happens is done through the management aspect of the tree scale that I've mentioned to you guys in my previous talk. All right, so I have a few, so that's my customer API. So this is pointing through the tab that is called APIs. This is where you go and you will define your APIs. Build over a few of those, and this is the one that we're currently using. So there's the definition of the API, there's its settings, and this is the big important part that basically tells it what it is. So there are choices in terms of security, how you're going to secure this API. This one is only secured with API key, but obviously we support OAuth, and you can enforce any security that you decide to, and gateways will enforce it. This is the URL of the API, so the gateway will know where to forward it. And then I have a flying here. And this one is basically the key that I've issued for myself to have an access to bypass security. So now I have to hit the API not only with the RESTful path, but provide a H. So if I remove this, I should get that I cannot get it, right? Because I did not fulfill the contract. So looking back at so this is how you work. You onboard an API, you define it, you create its integration stuff. But then when you do provide documents for it, so I have a few of those here that define what this API is in terms of Swagger. You can build your own flavorized developer portal. I did little customization of for today. So normally you have. This is, public, either public facing or internally facing. In terms of nicer ones, this is one of our public customers, Schiphol airport in Amsterdam was one of the adopters. Campbell's soups, you know, and recipes are a very excellent example of how nice these portals can be in terms of providing information for APIs that they offer to a public. And as you see here, those are the ones that are running on the 3 scale. So that's how you kind of, you know, build your API management, right? And if you run the APIs, then you collect the data, you can do reporting on it and gather information and et cetera, et cetera. Last thing I want to show you is, all right, so as I said, the GUI is browser-based, is running OpenShift. You use exactly the same technology, it's just the level of abstraction as you interact with the designer is much higher. At the end, you still build a Fuse camel code out of it that gets compiled and produces container. But you kind of, you know, completely abstracted to it. So when you think of it, I've built one integration here that is called pay recurring bill that pulls the data from from a database. So it's a puller that has a scheduler that samples a table for new rows. Then does the transformation of the data from a SQL selected statement into a preparing RESTful API call, and then calls the RESTful web service. So I can publish this thing, and what you will see is it will take a little while, and it's happening really, you know, behind the scenes. What we were just doing is building a container, compiling and building a container. And again, you know, let me just when this is doing, you know, I can show you an edit. So this is a designer. So you will see the database as a source. Then you have multiple steps that you can do, and then there's a destination that you configure and wire it. And so on the database layer, you provide a select statement, and how often you sample the database. On the other end, you provide the actual method from the RESTful API that you're going to call. On the data mapper, okay, done. This is what's happening here. This is how this data gets mapped. It's very simple. So as a demo. And so this is still publishing. When it finishes, basically you have a running container. And again, the aim is here to build sample integration. If you have anything of serious work to do, you will use traditional Fuse deployed in a traditional way or in a containerized form. But like I said, there is a demand. We have connectors to Salesforce, to Twitter, to other social media that you might go after and integrate with to pull maybe non-essential business data, but well, maybe today everything is essential, even things that are being said on the social media, right? So that is pretty much, you know, has this, this have completed, so I can use that application to send my recurring bill. I don't know to whom I'm paying $200, but so the activity should pick up soon. You'll see the number of total messages that is going through. You know, is going to go up, and it will basically, as you see already, working and publishing. You can actually can go to OpenShift layer from it and make a switch. So those are a few success stories that we have recently. Vodafone, UPS, and Lufthansa that adopted these technologies. Pretty much all of them Fuse and, and containers, as well as 3K API management. In both cases, what Vodafone was looking for is really for internal agility. They have a central gateway implementation that was running on IBM Data Power, and because it's a hardware base, was not scaled, was not supporting their initiatives in the cloud. So they've started to use Fuses for it. UPS integration, as I said, with all these social media outlets and through the hybrid environments. And Lufthansa, basically, having old systems that are still have quite a number of years in front of them, want to expose them in a modern RESTful API way. And that's where Fuse and 3Scale came in. This is the white paper, excuse me, that I mentioned that you can read about Agile integration and through and all the stuff that I've referenced is quite there. So feel free to download it and we'll share that with you. Thank you very much.